Okay, Calc BC, Unit 3, Day 12, worksheet, office hours. These are the answers, are multiple choice, but you gotta show work. Multiple choice is as much work as non-multiple choice. Sometimes it's more work because you have to deal with their tricky answers. So check those answers, and then I'll go over them. So D, E, number 1's D, number 2's E, number 3's A, 4C, 5A, 6D, 7B, 8A, 9D, 10E, 11E, 12E, 13C. All right. They are non-calculated unless they say so. So rectangular equation. So rectangular, that's Cartesian. And if you just look at the answers, that's one benefit of multiple choice is that you can look at the answer and be like, oh, that's what I'm trying to do. So you probably want to solve for t in terms of x. So I think we would want to isolate the exponential and then take the natural log of both sides. And that would give you negative t. And then so t equals negative natural log of x minus 1. And then we're going to plug that into the other equation for where the t is. So it's going to be y equals 1 plus e to the negative natural log of x minus 1. And we want the e and the natural log to cancel out, but you got to bring this in as an exponent using the power rule first, and then those can cancel. So you get y equals 1 plus 1 over x minus 1. And you could write that, but I don't see that answer. This is an example why it's going to be more work. That would be fine. But I guess maybe we got to try and do like least common denominator. So that'd be x minus 1 plus 1 over x minus 1. So y equals x over x minus 1. The answer is D. So, all right. So that'd be like a rational function. So this is the way you'd write a parametric version of like a rational graph. Number 2, curve in the plane is defined parametrically. They're giving you the positions. Finding equation of the tangent line at t equals 1. So we need the x and y coordinates, which are really easy to find. And so that's the point we're going to use. But then we need the slope, dy dx, which is going to be dy dt over dx dt. And so dy dt would be 2t plus 2, and dx dt would be 2. So then we're going to plug t equals 1 in there. And we get 4 over 2 is 2. So that's your slope. So we're going to do y minus 3 equals 2 times x minus 5, which would normally be totally fine for your answer, but because it's multiple choice, we have to change it to slope-intercept form, it looks like, based off the answers. So the answer is E. All right. What is the following is an equation of a line tangent to the curve of the parametric equations. So this is the same kind of question, looking for the equation of the tangent line. So x0 is 3, e to the 0 is 3, 6 e to the 0 is 6. So the point is 3 comma 6. Then we need dy dx, which is dy dt over dx dt. So dy dt is 6e to the t. Dx dt is going to be negative 3e to the negative t, which would be negative 2 e to the 2t if you use rules of exponents. And then we want it at time 0. So it's going to be negative 2e to the 0, which is going to be 1. So it's going to be negative 2 is your slope. So y minus 6 equals negative 2 times x minus 3 would be fine on any other question by multiple choice. These look like some of them are standard-ish form, some of them aren't. So y minus 6 equals negative 2x plus 6. So we can maybe try and figure out which one it looks like it's going to be. I don't think it's going to be either of those because we have a negative 2x. So it's got to be one of these ones up here. So I think we should go and just move stuff over here. So we can add 2x, subtract 6. Didn't mean to do that. 2x plus y minus 12 equals 0. So that looks like answer A. Okay. Number 4, parametric equation. What are all the points on which the curve is a vertical tangent? So that's going to be dy dx equals undefined, which is going to be dx dt equal to 0, and dx dt is negative 4 cosine t. So that's when cosine t equals 0. So that's going to be t equals 0 plus, I'm sorry, cosine equals 0 at, yeah, so it's going to happen at pi over 2 plus pi k. So pi over 2, 3 pi over 2, 5 pi over 2 is too much, right? So it's looking like that. Now the thing you got to watch out for is you got to make sure that dy dt doesn't equal 0 at the same time. If it does, then we just got to do extra work. It's okay. So it's going to be negative 3 sine t. And so that would be when sine t equals 0, which would be 0 plus pi k, which would be 0 pi 2 pi. So we're good. Okay, we're okay. Okay. Now here's the deal. They're not looking for the times, they're looking for the coordinates. So we still have to plug these back into the original equation. So we got to find x pi over 2, which is going to be 3 minus 4 sine pi over 2. Pi over 2 is 1, so it's going to be negative 1. And then y pi over 2, which is going to be 4 plus 3 cosine pi over 2. Now cosine pi over 2 is 0. So that's going to be 4. So one of the points is going to be negative 1, 4. It's one of them. So we can eliminate that and that. So then we're going to find x at 3 pi over 2, which is going to be 3 minus 4 sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1, so that's going to give you 7. And y of 3 pi over 2 is going to be 4 plus 3 cosine 3 pi over 2. Cosine 3 pi over 2 is 0, so that's going to be 4. So the other point is going to be 7 comma 4. So the answer is going to be C. All right. Number 5, we're trying to find the second derivative. Now remember, the way, I don't know if you can remember the way we said, well, we're going to take dy dx and take the derivative of it again. But dy dx is in terms of time, so we're going to end up first taking the derivative with respect to the variable that it has, but then following up by the derivative of the variable it has with respect to x. Chain rule. And so then this is what we end up getting. Okay, or you can memorize it, but it was really hard to memorize. So first of all, dy dx equals t cubed over 2t squared, which is going to be t over 2. So then we're going to take the derivative of that with respect to time, and that's going to give you 1/2. And then you're going to divide by dx dt, which is 4t. Hold on, I messed up. I'm going to take the derivative of this. dy dx equals dy dt over dx dt. And so this should have been 3t squared over 4t, which would give you 3/4 t. So then this is going to be 3/4. and then we got to divide by dx dt, which is 4t. So this is going to be 3 over 16t. And then we're going to plug in time 3. So it's going to be 3 over 16 times 3 is going to be 1/16. 1/16. Okay. Number 6, same kind of thing. So we're going to find dy dx first, which is going to be, remember this is the same thing as cosine t squared. So it's going to be 2 cosine t to the first times derivative of what's inside is going to be negative sine t over derivative of sine is going to be cosine t. So those are going to reduce. So then we're going to take the derivative with respect to time of that. And we're going to get negative 2 cosine t. And then we're going to divide by dx dt, which is cosine t. And this is always negative 2 no matter what time. It always has the same concavity. So maybe because it's like a circle or something. I think it is. All right, number 7, particle moves the xy plane at any time. It's x coordinates, so they give me xy, time 1, acceleration vector. Now, this is different. This is second derivative, but not that kind of second derivative. This is second derivative of y with respect to time, second derivative of x. So we probably want to find velocity first in the x direction, which is going to be x prime. So that's going to be 2t. And then we can find the acceleration by taking the derivative of velocity, or the second derivative of position, and that's going to be 2. And the velocity in the y direction is going to be the derivative of the y position, which is going to be negative 3t squared. Acceleration in the y direction is going to be the derivative of the velocity in the y direction, or the second derivative of position, which is going to be negative 6t. So acceleration in x direction at time 1 is going to be 2, and acceleration in the y direction at time 1 is going to be negative 6. And then we usually write it as a vector, 2 comma negative 6. And you could just use regular parentheses too, that's fine. Whatever. But usually use kind of the sharper ones a lot of times. Okay, number 8. A particle moves the xy plane. So given kind of more generic x position, alpha and beta are constants. The y component of the acceleration is, they just want the y component of the acceleration. So you just want ay at any time. Okay, well, let's find vy, which is y prime. And that's going to be alpha beta cosine beta t. And the acceleration is going to be the derivative of y, second derivative, the derivative of velocity in the y direction, on the second derivative of y position. That's going to be negative alpha beta squared sine beta t. So there's just chain rule going on here. So negative alpha beta squared. Oh, shoot. Let's see. I don't see this answer on here, but look, there's a couple weird answers on here. There's a couple that have y and x in it. Check this out. Alpha sine beta t, that's just y. So this could be negative b squared y is another way of writing it. Man, that's tricky. So I'm telling you. That's a choice. Or extra. Okay, number 9, particle move the xy plane, t is greater than 0, coordinates, they're giving you xy. What's the velocity vector? Oh. So velocity in the x direction is going to be the derivative of the x position, which is going to be product rule et cosine t plus sine t et. Okay. And then, so if you plug pi in, e to the pi cosine pi, which is -1, plus sine pi e to the pi, well, that's 0, so you're going to get negative e to the pi for velocity in the x direction. Velocity in the y direction, it's going to be y prime. So that's going to be e to the t times root of cosine's negative sine plus cosine e to the t. So we're going to plug pi in. E to the pi times negative sine of pi is 0 plus cosine of pi e to the pi. Cosine of pi is -1, so it's going to be negative e to the pi also. So the answer is going to be negative e to the pi, comma negative e to the pi. And we usually use kind of these sharper brackets for velocity vectors. Velocity at time pi. But whatever, they can be parentheses also. Okay, number 10, the velocity vector of particles. So this is Vx and Vy. The path of the particle lies on what? What kind of shape does it lie on? So x prime t equals 4t, y prime t equals -2t. So maybe we could try and go backwards to find the x and y equations. So we say, well, xt is going to be the integral of x prime t dt, which is going to be the integral of 4t dt, which is going to be 2t squared plus c. Right? Okay. And then y is going to be the integral of y prime t dt. It's going to be the integral of -2t dt, which is going to equal -t squared plus c. Okay. Now, if we were trying to solve these to get a Cartesian equation, what would it look like? Well, I'm going to call this c sub 1, c sub 2 because those are different constants. But I would probably solve for t squared here. So I guess a t squared equals x minus c1 divided by 2, and then plug that into here. So I get y equals negative x minus c1 divided by 2 plus c2. So y equals -1/2 x plus c sub 1, 2 plus c2. So this is the Cartesian equation. It's definitely a line of some kind. But they also told you t has to be greater than or equal to 0. So that means that t equals 0 is a starting point. I mean, you could do a little table if you want. If you plug 0 in, you get c sub 1, c sub 2. That's your initial point. And then if you go to infinity, well, this is going to go to positive infinity, and this is going to go to negative infinity. So if you're to graph this, there's some, not that you need to. I think at this point we should realize it's a ray because it has an initial point and no terminal point, so it keeps going forever. So it's a ray. I mean, what the graph looks like, though, is it has some c1 over 2 plus c2 y-intercept, and then it goes down 1 over 2, down 1 over 2, and it just goes. It's like this, but it's just this portion of the graph. And this is its direction. So it's a ray. Okay. 11. Curve is given parametrically. Give the length of the arc. So length of the arc is the integral of speed, just like last year with 1D motion. But now speed is the square root of dx dt squared plus dy dt. squared dt. I'm going from 0 to 2. So it's going to be, and we don't have a calculator, and these answers all look nice, so I guess we're going to do it by hand. So dx dt is going to be 3 minus 3t squared. Dy dt is going to be 6t squared. So I guess we're going to try and work this out. Okay, that's going to be 9 minus 18t squared plus 9t to the fourth plus 36t squared. And so what's that going to be? That's going to be neg 9 negative 6t squared plus, well, hold on. This should be 9t to the fourth. So it's going to be 9t to the fourth minus 15t squared plus 9. Okay, now maybe that's a perfect square. Let's see if we can factor this. This would be 3t squared, 3t squared. I'm just hoping, I'm basing off my hope. And it would be, I don't know if that's going to work. Let's just make sure I didn't make any mistakes. I feel like I did. Oh, this is 36. So this should be positive 18 in the middle. And that works a lot better. Plus 3. I knew something was wrong. I don't know, just because the only way this is going to work is if we get rid of the square root somehow. And we do, so now we're going to integrate it, get t cubed plus 3t, 0 to 2, plug 2 in, you get 8 plus 6, plug 0 in, you get 0 plus 0, and the final answer is 14. All right, made a little mistake there. Okay. Number 12 and 13, we can use graphing calculators. So let's see if we can do that to help us. The velocity of a particle moving the xy plane. So this is Vx and this is Vy. T is greater than 0 when t equals 0. Point is, so this is x0 and y0. Which statement best describes the motion of the particle? Well, I mean, we could graph it. And, I mean, if we're allowed to use a graphing calculator, I mean, it says it moves around a circle. So, I mean, we can put it in parametric mode. Go y. Type. See, these are velocities, though. So I don't know if we're ready to do that. We could try and do what we did earlier, where we said, okay, well, if we could try and get x from x prime, right? We could do fundamental thermodynamics too. I don't know if that's going to help, but we'll use this as to help us find the c value. Hopefully we can integrate these. It looks like we can. So 3 minus 4 cosine t dt is going to be 3t plus 4 sine t plus c. And then if we plug times 0 in, we should get 0. So 3 times 0 plus 4 times sine of 0 plus c should equal 0. That's 0, that's 0. So c equals 0. So we got our x equation. It's 3t plus 4 sine t. And we'll try and do that with y real quick. Y prime t dt. 3t squared dt. It's going to be t cubed. Right? Plus c. But we're going to plug 0 in. 0 cubed plus c. It should equal -1. So c equals -1. So yt equals t cubed minus 1. Now, can we find the Cartesian equation from these? I mean, I don't know. I mean, here's the deal. As t, this, let's just start to look at the behavior. As t goes to infinity, x goes to infinity. As t goes to infinity, x goes to infinity. And there's this little tiny thing where it goes kind of forwards and backwards a little bit. And then as t goes to infinity, y goes to infinity. Y just keeps getting bigger and bigger. So I don't think it's not a circle. I mean, that's not a circle. Circles have to come back around. It's not a sine curve. The particle moves to the left. No, it's moving to the right. Right? So I think those are all out. Particle moves to the right with a regular up and down motion. Yeah, it's kind of going. I mean, no, it's just kind of going up. It's the x position that's kind of going back and forth. Particle moves generally to the right with a regular up and down motion, but periodically loops to the left. I feel like this is the best interpretation of it. Now, at this point, we could plug this in and actually see what it looks like. 3x plus 4 sine x t t to the third minus 1. Window, I mean, we could say 0 to 20 for time. I don't know, negative 10 to 10, negative 10 to 10. I don't know what this graph's going to look like. Time is always greater than 0, so I think we go back to window and it looks like the graph got really big. We don't, it doesn't look like there's x values. I mean, the graph just gets really gigantic. I mean, maybe we're missing, but it does come to the left a little bit. Maybe here's the graph. It's going left, but it just blows up. I'm assuming it's got to come back, but it's, I don't know. My graph needs to be bigger or something. But I mean, I don't know. Yeah. So I mean, E makes the most sense. It's not always moving to the right. I mean, I don't know if I need to make my Y max just really super tall or something. 1,000. Let's try that. There's the graph. Oh, yeah, that is crazy looking. So I think it does come back, and then it's a weird looking graph. But, okay. 13, two particles, alpha and beta, race for the y-axis race from the y-axis vertical line, x equals 6 pi. Alpha's position is given by parametric equations, and beta's is given by that for t is greater than 0. Which sentence best describes the race and its outcome? Well, what we're trying to figure out, the racing to try and get to this line, x equals 6 pi. So, maybe we could just find their initial coordinates at time 0. So that's going to be 0. And y alpha is going to be 0. So alpha starts at 0, 0. Okay. And then beta 0 is going to also be 0. Y beta at 0 is going to be negative, it's going to be 3. So beta starts at 0, 3. So we're both starting at x position at 0. So I guess that makes sense with race. They're a little spaced apart. Now, what would be interesting to try and figure out, well, when does alpha get to 6 pi? So let's set the equation equal to 6 pi and solve it. Now you have a calculator, which I think is going to make this way more easier to solve. So I would do 0 equals 3t minus 3 sine t minus 6 pi, and then use my calculator to solve it and figure out which one gets there the first. And I'm going to do the same thing for beta and set it equals 6 pi. 3t minus 4 sine t. So 0 equals 3t minus 4 sine t minus 6 pi. And then I'm going to solve that on my calculator. So I'm going to solve these not in parametric mode, but there is something interesting we can do. So I'm going to go to y equals, and you do one of these at a time. 3x minus 3 sine x minus 6 pi. Window, I'm going to say 0 to 10. And all I care about are the x intercepts. And hopefully I just really care about the first one. So there's one right there. So that's when alpha first gets there. It's around 6.5 maybe. It is 6.2833503. And then we do the other one, 3x minus 4 sine minus 6 pi, graph it. There's that one. That one looks like it happens around 5. So second calculate 0, 4 to 5. Guess 5? I don't know. Okay, never mind. Say 4 to 6, guess 5. 5.0074887. So I would say that beta wins the race. Now, I don't know. I think some of these, it says beta starts out in the wrong direction. I'm not sure about that. Alpha takes a shorter path and wins. Well, alpha definitely does not win. Alpha moves slower and loses. Well, they definitely loses. Beta moves faster and loses. No, it doesn't lose. Alpha and beta tie. No. So I think it's between, A and C. They both, alpha loses, beta wins. But did beta start out in the wrong direction? Well, I mean, I guess the best thing to say is to say, well, what's the velocity of beta in the x direction at time 0? So we could go, here we go, math 8, and we could put in the equation for x beta 3x minus 3 sine x close comma x comma 0 and figure out its velocity. Its velocity is essentially 0. 0.0000004999. So it's not starting off in the wrong direction. Now here's another interesting thing that we can do. We could go to polar mode. No, actually we can go to sequential mode. And then go to y equals. No, that's not what I wanted. Maybe go to polar mode. Let's see. Okay. And then we'll change this to simulate instead of sequential. Sequential means they do one and it does the other, but let's enter them in as polar equations. Oops, not polar equations, parametric equations. So the first one is 3x minus 3 sine t, and then the y is 3 minus 3 cosine t. And then the next one is 3t minus 4 sine t. And the next one is 3 minus 4 sine t. And what this will do is it'll graph both curves at the same time. And it's like we can see them racing. So I'm going to make this line different. So alpha's the dark one. No, alpha's the regular line. Maybe I'll make alpha the dash line. Alpha is the dashed line, beta is the dark line, and we're going to graph them. Now the window needs to be big enough. I mean, look, based off these times, we could do like 0 to 10, x-min, I don't know, negative 10 to 10, negative 10 to 10. I don't, the x, maybe we could just do negative 1. And by the way, we're trying to get to what, 6 pi? So we put 6 pi as like the right boundary. We can kind of see what happens here. And it's hard to tell. Okay, let's make a window a little better. Maybe just like in the y direction, negative 2 to 9. Now let's watch this. So there's beta. It does look like beta is going in the wrong direction. And there's alpha. And beta kind of speeds up to catch up and win. And then beta actually comes back for a victory lap or something. But beta definitely wins. It does say that beta starts out in the wrong direction and loses. Okay, well, that one's out for sure too. So it for sure has to be C. That's the only one that has alpha losing and beta winning. You know, and they don't tie, but that's it. Kind of interesting. It's interesting if you find the length. I did this. It's kind of interesting. Beta does take a slightly longer path to get there because it does kind of go backwards a little bit at the beginning. Maybe not right at time 0, but at some point it kind of beta goes backwards.